This video lesson is going to cover the basics of inequalities and graphing them. I recommend you have a pencil and a paper to take some notes down, and of course a growth mindset. So if you get a little frustrated or you don't understand something, you overcome that and keep trying. The goal of the video is that when you see an inequality like either of these, you're going to understand why the graph matches the inequality or how to generate the graph from the inequality. There are a lot of mathematical symbols out there. I mean, look at these and these, just so many. So today the goal is for you to better understand the inequality symbols. And just for fun, a little bit of review about the basic inequality meaning.
There was an alligator living in the swamp. He'd sneak up on numbers and start to chomp. Whenever two numbers sat on the ground, she'd face the bigger one and gobble it down.
You can always go to YouTube and watch more if you like that, but otherwise I'm going to move on from the cringiness and go to the review. So if you don't like the alligator analogy or you didn't learn that, just look at the symbol itself. The little pointy part of the symbol tells you that that side is the less than side, and the open part where the space between the symbol here is greater than, it's open, it's wider, that tells you that that's the larger value. So 5 is less than 9. And then here, 3 is the larger value, so the open part is going to face the 3, and the number line shows larger values will be on the right and smaller values will be on the left. Here we have a negative and a positive value. Well, negative values will always be less than a positive value. If you have debt, you owe someone $4, that means you have less money than someone who has $1. And on the number line, the negatives will always be further on the left than the positives. And so therefore this one is less than. Now, here's where people tend to get these mixed up because you have to think about what it means. A negative 10 is further on the left and a negative 6 is further to the right and closer to 0. So if you owe $10, negative 10, that means you have more debt and you technically have less money. So negative 10 is a smaller value than negative 6. Therefore, negative 6 is greater than negative 10. Here are some for you to try. Well, a negative will always be less than a positive. A tenth is less than 5/10, so therefore it's like that. So if you look at a number line or think about it, negative 8 is further to the left and it's a smaller value than negative 3. And here, if you think about money, $6.80 is more than $6.08, so therefore 6.8 is greater than 6.08. Now I want to talk about the difference between an equation and an inequality. I think it helps to think about money. So I like Billie Eilish, so I looked up her concert tickets, and the nosebleed section here is going for $95.91 plus fees. So I figure, the fees are usually about $10 or so. So if I want to go to the concert, M is going to equal the amount of money I need. And I'm putting 106 because of the fees. So the ticket is about $106. So to go to the concert, I need exactly $106. That's an equation. But in reality, I'm going to this concert. I'm probably going to want to buy food, some souvenirs. Parking is usually crazy expensive. I recently went to Disney on Ice and they charged $40 for parking, which shocked me, to be honest. So therefore, an inequality will make way more sense in this situation. The money, we want the money we're going to bring or earn to be more than $106. So therefore we can do these other things. Or you can think of it as the money could be equal to, this little line down here means it could equal $106. We'll have exactly the amount we need for a ticket, or the money needs to be greater. So that's how an inequality varies from an equation. Equations can be very useful when we want exact amounts, like if we're measuring something and building a bridge, or for medication, you're supposed to take exactly 5 milliliters, not more than 5 milliliters. So an equation tells you exact, and an inequality tells you less than or more than, and it kind of gives you more of a range of values. For example, if I wanted to know all the values less than 5, I want you to tell me every single value less than 5. How many values are there? There's a lot. There's an infinite number. Think about it. 4, 3, 2, 1, 0. We have all our negatives. We could go to negative infinity because negative infinity is less than 5. Well, those are just the integer values. What about all the rational decimal and fraction values in between? Well, there's an infinite number of those because we have 4.91, 4.92, 4.9222. So just to emphasize, there's an infinite number of possibilities. Therefore, we use the variable, or a variable, doesn't have to be x, to represent all the values. The less than symbol and the 5. So this mathematical statement right here is representing all values less than 5. And on a number line, we can represent this statement with an open circle at 5, because that tells us it's not 5, but it's everything less by drawing an arrow to the left. And this arrow tells us everything in here, the 4.9 repeating right next to the 5. The -1, the negative infinity, this arrow tells you it goes on forever. So this graph and this inequality include an infinite number of solutions. So the inequality symbols that you are expected to know and exist in mathematics, we read them from left to right when we're not having anything else to refer to. For example, this is the smaller point, so this is less than. And then over here, the larger open mouth part is on the left, so therefore this is the greater than symbol. And if we were going to graph this, this is all values less than 11 because it's a less than facing the variable. And over here, this is all values greater than 11 because the greater than is facing the variable. So to graph, this one is going to be an open circle because it's not equal to 11. It's just less than 11, so pointing to the left. And over here, open circle, because it is not equal to 11, but it's everything greater, so pointing to the right. Now, if we have a less than and we combine it with an equal to, the graph of less than points to the left because all values that are less or smaller are going to the left. Equal to is a shaded in dot because it's equal to, and therefore the symbol looks like this. It's a combination of a less than and an equal to, and the graph is a shaded in because of equal to pointing to the left. And then the other version of this, which is more than and an equal to, we have a graph that points to the right because greater than is to the right. Equal to is shaded in, and we combine these together. It looks like a greater than or equal to, or you could say more than or equal to. The graph is pointing to the right and shaded in. So once again, this is not what the symbol looks like, actually. I put an extra line here to reinforce less than or equal to. Mathematicians do not include the second line, though. So this little single line is what represents the equal to. So I just want to emphasize it looks like that, not like this. But that one little line is equal to. And then the flip version, greater than or equal to, once again, will not look like this, trying to emphasize that that one little line means equal to, but you won't see the two lines. So to graph these, all values less than or equal to 11 versus all values greater than or equal to 11. The one on the left here, shaded in because it could be 11. It's equal to, and it goes to the left, less than. And then over here, we have our greater than or equal to 11 pointing to the right because it's greater than, or it could be equal to 11. And then another symbol, the not equal to symbol. So if you have an equal to, it's going to look like this. It's a boring graph, just a dot at 11, x equals 11. Versus if the values do not equal 11, that means you have an open circle at 11, but it's everything else. So it's not just that. That would be no solution. That would be nothing. There's just an open circle on the graph. You have to have an arrow pointing to the left and right to represent all the other values, an infinite number of values that do not equal 11. So here's all the ones I just covered. Just want to reinforce. Equations have one solution. A boring little dot graph here tells you it's just that one number. That's the only answer. Versus all these other ones have an infinite number of solutions. This arrow tells you it goes on forever, and the line tells you that there's an infinite number of values in here. You would have 10.5, 10.1, and then everything to the left. So once again, arrows say it goes on forever, and the line itself has an infinite number of dots and numbers within it. Last but not least, just want to make sure that you try some of these about what they mean. I'll do the first one to explain. So this first one, x is less than 1 means values less than 1. So the solutions are values or numbers less than 1. So what's the next one? Well, that's values that are more than 3. The value is not equal to 5. the values are less than or equal to 7. And this one, the values are more than or equal to 9. So there were a number of different things covered in this lesson. Nice work. This next step is I just want you to do some practice. So on Delta Math, you're going to have this just more basic inequality practice where you're going to be pushing true or false based on the inequality. I couldn't turn the timer off. I don't like the timer, but therefore I just made the timer really high. You have 10 minutes to do 5 problems. They should not take you very long at all. They probably will take some of you less than a minute because, for example, -6 is less than 7. That's true. You'd push true. And then the next one, you would just answer true or false until you get to 5. And then the other practice is on solving equations with the distributive property that we had been working on in the past. See you at the next video lesson. Nice job, everybody.